So hi everyone, welcome to this session, Introduction to Bigquery. Today I am Asif Ali. I will be talking about Bigquery. So it will be a basic introduction to Bigquery. So first we should follow knowledge etiquettes, punctuality. Join the session 5 minutes prior to the session start time. We start on time and conclude on time. And make sure to submit a constructive feedback for all sessions as it is very helpful for the presenter. Keep your mobile devices in silent mode and feel free to move out of session in case you need to attend an urgent call, and avoid unwanted chat during the session. So now our agenda will be what is BigQuery, features of BigQuery, architecture of BigQuery, and why should we use BigQuery, bring any data into BigQuery, and then we will look into our lab. That will be a quick lab. So if you are familiar with a quick lab, then you can like get it very easily. So it will be a like we will perform some operations in there like in a practical way. So what is BigQuery? BigQuery is a cloud-based data warehousing and analytics service provided by Google. It allows you to store, query, and analyze large data sets using a SQL-like language. BigQuery is a serverless and cost-effective enterprise data warehouse that works across clouds and like scales with your data. Use built-in ML and MI for insight at scale. It is a serverless and cost-effective enterprise data warehouse that works across clouds and scales with your data. It is a cloud-based big data problem-solving web service for processing massive read-only data sets. BigQuery provides fast and interactive analysis with a familiar language like SQL, cloud storage, and open source software on compute engines such as Hadoop provide ATL, means extract transform load workload. So ATL basically it is a ATL job like where we can extract data from source and then perform some operations and then like perform a transform and then load the data into a BigQuery. BigQuery was specifically designed for examining data on the order of billions of rows using a SQL. You can analyze terabytes of data in a matter of seconds through like SQL-like queries. With BigQuery, you can upload your data to Google Cloud Storage and then use BigQuery to analyze the data without having to worry about the underlying infrastructure. BigQuery can handle petabytes and scale dataset can perform queries on them in seconds. Features of BigQuery. So first is SQL-like language. So it provides BigQuery uses a SQL-like language to query data, making it easy for data analysts and data scientists to work with data without requiring specialized programming skills. Then scalability. BigQuery is designed to handle massive data sets from gigabytes to petabytes of data and can process queries like quickly and efficiently. Cost effective. BigQuery offers a pay-as-you-go pricing model, which means you only pay for the amount of data you store and the queries you run. Integrations. BigQuery integrates with other Google Cloud services like like Cloud Storage, Dataflow, and Google Data Studio, making it easy to ingest and analyze data from a variety of sources. Then machine learning. BigQuery integrates with Google Cloud's machine learning tools, making it possible to train and deploy machine learning models directly within BigQuery. BigQuery can ingest data in real time from sources like Google Cloud PubSub, making it easy to analyze streaming data. Security. BigQuery offers several security features such as data encryption at rest and in transit, identity and access management, IAM integration that is used for security and compliance with various data protection regulations. Data visualization. BigQuery integrates with tools like Data Studio, making it easy to create compelling visualizations and dashboards. Now, architecture of BigQuery. So here you can see BigQuery provides this like user interface. BigQuery provides a user interface that allows users to interact with their data and run queries. So here, this is a user interface we can see, and like we can use REST API, Web UI, or BQ command line tool to use like to get data from BigQuery or load the data into BigQuery. And there is also a execution engine that is called Dremel. And like BigQuery architecture separate the concept of storage and compute and allow them to scale independently. So here you can see Colossus and Dremel and Jupyter Network. These technologies are combined, and then Google provides this service with combining these three services, or we can say that like multiple services. And then here is a query engine tree. So and Jupyter Network is a middleware between Colossus that is distributed or storage and the Dremel execution engine. So BigQuery architecture separate these concepts. And query engine. BigQuery uses a column-based storage format. Like we also can call this as a query engine or processing engines. BigQuery uses a column-based storage format and a SQL-like query language to analyze data. It supports real-time querying of large data sets using a multi-version concurrency control architecture. BigQuery executes queries using a distributed computing model called Dremel, which is based on a tree architecture and design to process structured and semi-structured data at high speeds. BigQuery also has a separate engine called BigQuery ML, machine learning, which allows users to create and execute machine learning models directly within the BigQuery environment using SQL. Like Query Engine is the heart of BigQuery's architecture. It allows users to run SQL-like queries against the data stored in Google Cloud Storage. The query engine is designed to handle massive dataset and can process queries quickly and efficiently. Storage options. BigQuery stores data in a distributed columnar format in Google Cloud Storage. This allows for efficient and cost-effective storage of large datasets. BigQuery also has a feature called federated query, which allows user to query data that is stored in external systems such as Google Sheets or Google Cloud Storage or any other. Like we can load data from our local system as if it was stored directly in BigQuery. BigQuery supports a variety of storage options, including standard storage, which is suitable for most workloads, and cold storage, which is less expensive but has longer access latencies, and nearline storage, which is a balance between the two. Then Jupyter Network, it is a middleware. In addition to disk input-output network speed, it often limits large data load because of the separation between the compute and storage layers. BigQuery requires an ultra-fast network that can deliver terabytes of data in seconds directly from storage to the Dremel job. Jupyter Network is the bridge between the Colossus storage, that is distributed storage, and the Dremel execution engine, that is query engine. The networking in Google's data centers offers unprecedented levels of bidirectional traffic that allows large volumes of data movement between Dremel and Colossus distributed storage. Why should we use BigQuery? So there are multiple reasons to use BigQuery. Building and scaling tables are comfortable. BigQuery makes it easy to build and scale tables to handle even the largest datasets. You can scale up or down as needed, and you only pay for the storage and processing that you use. You don't need to pay extra, like in the monthly or weekly basis. Easy and fast. BigQuery allows you to quickly and easily analyze large amounts of data using SQL-like queries. This makes it possible to get insight from your data in real time without having to wait for data to be transferred or processed. Prerequisites are minimal. You don't need to have a very heavy system to use BigQuery. You don't need to any special hardware or software. All you need is an internet connection and a Google account. Access control at the project, dataset, and field level. BigQuery allows you to set fine-grained access control at the project, dataset, and field level. This helps you to ensure that only authorized users can access your data. Ease of use. BigQuery offers a SQL-like interface that is familiar to many data analysts and data scientists, making it easy to query and analyze data without requiring specialized programming skills. Bring any data into BigQuery. Make analytics easier by bringing together data from multiple sources into BigQuery. We can upload data files from local sources, Google Drive or Google Cloud Storage. This example we will see in our practical lab. Use BigQuery Data Transfer Service (DTS) Cloud Data Fusion plugins. Replicate data from relational databases with data stream or for BigQuery. Loading data into a data set. Like we can load data from multiple sources, like streaming insert. We can stream data into BigQuery in real time using table data.insert old method of the BigQuery API. This is a good option if you want to ingest data in real time and don't have a lot of data to load. And then batch imports. You can use the BQ command line tool or the load method of the BigQuery API to load data from a file in cloud storage from a local file. This is a good option if you have a large amount of data to load and don't need it be available in your real time. Exporting data from another service. Like you can use the export method of the BigQuery API to export data from another API or another service such as Google Analytics into a BigQuery dataset. Now we will see we will look into a lab. Let me show you. So this is a very like quick start lab to use BigQuery. So it will give a very introduction part of the BigQuery, and it only takes 10 to 15 minutes, and it gives 30 minutes to complete this lab. So I will start and I will show you how it looks like. Google provides a virtual environment to use this service. This is our overview. Storing and querying massive data sets can be time consuming and expensive without the right hardware and infrastructure. BigQuery is an enterprise database that solves this problem by enabling superfast SQL queries using the processing power of Google's. So here in this lab, what we will do, we will query a public data set and then create a data set, load data into a new table and query a custom table. Let me open this. Actually, let me open in a incognito mode. We should perform. It will be very helpful. Okay, let me open this on another screen. My screen is visible, like I am logging into a Google Lab. So it is visible to you?
No, sir, it's not.
Oh, sorry. Okay. Now?
Yep, it is.
Okay, so this is a hands-on lab that Google provides us to use BigQuery. So in this lab, we will perform some operations like query public data set and create a new data set, then load data into a new table and query a custom table. So I have logged in a virtual environment that is provided by Google. So it is a quick lab. If you're familiar with quick lab, or you can go with this one and use this free lab to explore BigQuery. Now, the BigQuery console provides an interface to query tables, including public datasets offered by BigQuery. The BigQuery you will run access a table from a public dataset that BigQuery provides. It uses standard query language to search the data and limits the results returned to the 10. Like we will according to the instructions in this lab. So like let me show you what I am using here. So this is a lab. Like here Google provides instructions how we can perform some operations. So I will use all of these information instructions to use BigQuery. So here are the tasks. Like we have 7 tasks. So I will perform these tasks to show you how we can get started with BigQuery. So in the navigation menu, here you can see this is a BigQuery service. So we can this is a BigQuery interface. Here, if you want to query a data set, so you can compose a new query, and then I will paste a query here. So that will basically select weight, pounds, state, year, and G station weeks. So as you can see, this is a green tick. A green or red checks displays a depending on whether the query is valid or invalid. If the query is valid, then the valid data also describes the amount of data to be processed after you run the query. Like you can see here 3.49 GB when we run the query. So let me run this one. So basically I am querying using this query in a public data set. So here you can see BigQuery public data dot samples nationality. I will show you where we can find this this data set we can add from here. So I will show you after the result. We can here you can see this is a result of this query. So now what I will do, I will create a table. First, this is my project. So this is a project, and then I will create a data set here. So basically, to load custom data into a table, we first need to create a BigQuery dataset. Then dataset help control access to table and views in a project. This lab uses only one table, but we still need a dataset to hold the table. Now, as given in the instructions, I will give the dataset name as baby names. So the data set will be a baby names, and then this is a location. So I will leave it as default, and this is a region like where you want to uh, use this data set. So we will take it as multiple region in United States. Let me create this one. So as you can see under the project, we have a data set named baby names. Now it's time to load data into this table. Like the custom data file we will use contains approximately 7 MB of data about popular baby names and provided by the US Social Security Administrator. Sorry. Now let me create a table. So from here we can create table inside our data set. So I will I will create a table from Google Cloud Storage. So if you know about Google Cloud Storage, so it is a container where we can access our files or store our files. So let me put the URL here. We will use URL. So we can browse here because we do not have any permission. As I told you already, like we can provide some roles to the users, like who can access what. Then I am not able to access buckets list here. So I will provide a URL that is provided by lab. Then as you can see the green tick, so we can access this file only. And then file format will be CSV. And now table name will be names 2014. So we can provide any name here. So I will put names 2014, and it will be a native, or table type will be native, and external table type will be like the tables that are data that is stored outside the BigQuery. But we will use native table. So here in schema we have two options. Like we can auto detect, so it will auto detect based on this file, then the schema will be auto detect. And we can also add the fields here, like I will add id and type and label, like as we do in our database. So what I will do, I will edit as text. So I can provide like id string. So I will provide three fields here. So it is an like name will be string, and gender will be type of string, and counter will be type of integer. Let me create. So as you can see, we have three fields here. And if I go for preview, then I can see the data. So as you can see, this is the 50 rows of these count of numbers. So this is our data, and now we will query this data. So I will select name and count from baby names 2014, where gender will be male, and order by count descending in five limit 5. So now our query is valid. Let me show you this example. Like if I put here invalid query, so it will show some error, syntax error. So let me here again. So our query is valid. Now I will run this query. So as you can see, this is the result of this query. And now let me show you how we can like add like public data set into our project. So this is the add button, and here are like additional sources where we can perform some operations. Like we can get data from Google Drive or Amazon S3. These are the options here. So but I will use public data set from Google. So like you can see, there are multiple public data sets. Whatever you want to use, you can use from here. So I will use about COVID-19 public data set. View data set. It will open in a new window. So as you can see, I have added this data set. So all the data sets are here. And then let me show you in our first query what we have like perform some operations. Like we are getting data from samples nationality. So let me show you this samples data set. So there are lots of data sets here. You can query from any of them. So this is the data set that we have like queried, and this is the table natality. So from table we were performing some operations. Like we have this query. In our first query, we have performed in this data set. Like I can select all. So, basically, we can use our SQL queries here, and we also can like create some views. Like this is a save options. Like you can save this query as a query or as a view. Like this query, like I want to create a view, so I will save this as a view. Our data set will be our baby names, and table name, like this view name will be example. So as you can see, we have a view here, example view. So I can like perform a query from this view. Like in this view, what we have, what was the query? So we have only 10 records. So I will query in this view. Select star from this, and I will not put the limit. I will select all the rows because it only contains 10 rows. So as you can see, this is a view. So this is all about the BigQuery. If you have any question, then you can ask any question. Hello, am I audible?
Yes, if you're audible, I guess the session was so good that no one is having any queries as of now.
Okay.
Okay, so still we'll ask it again with the attendees. Guys, if you are having any queries, you can please reach out to Asif right now, or else we can wrap it up over
Thanks,
here.
Asif, for the wonderful session.
Thank you. So we have performed very well. Like we get 100 out of 100, and now we can end this lab. You also can go with this lab. There are multiple labs provided by Quick Labs. So about BigQuery, like you can explore any lab from here, and you can like use any service of uh, Google Cloud platform. So like some of them are like chargeable. Like you should be like have like 6 credits or 11 credits to use these labs. But for BigQuery, if I search for BigQuery, some of the labs are very free. Like we have performed in our this example. So like as you can see, this is a free lab, BigQuery console start, and this is also free, and weather data in BigQuery. So basically this is also similar to this lab, this one, but it access some like public data set about weather data. So you can go with this one, or like there are multiple labs. Okay, thank you. Any question?
No questions till now. So
Okay.
thank you once again, Asif, for delivering such a nice session. And I'll request every attendee, like if they are having any questions further ahead, so they can directly reach out to you through any of the mediums. Okay. Okay. So I guess we can wrap it up over here. Thank you everyone for joining with us.